Hi there, and welcome back once again to video 5 in our series of tutorial videos on liquid physics 2D. So in this video I'm going to get a bit more technical, going to show you around the asset under the hood, as it were, show how it works, and have a look at the API. And also, as an example, we're going to write a script which will do something in the physics engine while it's running in real time. So before I start the tour, I'll just explain that this asset, what it mainly is what in Unity they call a plugin. So I'll provide a link to the documentation on this in the description below. But what a plugin is essentially you have a native library file of some kind, like a DLL perhaps, and you write an interface so Unity can call that. So in this case, the library is actually the Liquid Fun library, which is a C++ library. It's a superset of Box2D with particles in it. And I've written a kind of a C++ side to this interface that you can call from Unity. And then there are corresponding C# API functions, which you call from Unity to do stuff in your game. So I'll just show you these different elements right now. So if we have a look in the project view, look in Assets, Liquid Physics 2D. Well, actually, first of all, let's have a look in the Plugins folder. This is a special named folder in Unity, and this is where all the actual libraries go. So you can see there's the 4 platforms we support at the moment. There's Windows, OS X, Android, and iOS. So we have the 4 different libraries here for those. So there's a DLL for Windows, there's a .bundle for OS X. For iOS, there's actually just a flat directory structure of C++ files. And for Android, we have a .so file. So this is the library that does all the real hard work. Now to talk to that, we have the C# API functions. So now if you look in the Liquid Physics 2D folder, have a look in the API folder beneath that, and you'll see there's a series of C# files here. And what these are, we'll just have a look at one. Oh, for instance, we'll have a look at this LP API body. You can tell they all have the API prefix, so these are the API. So if we just scroll through this, we'll see that it's literally just a static class with loads of functions in them. I've put them in separate classes, so it's just kind of a bit easier to find them. And also you can see all these XML comments, so the summary and comments for all the parameters. So in your IDE you should be able to find these and find out how to use them easily, I hope. So just randomly have a look at some of these functions. So we've got set body type, set body position, set body rotation, set body linear velocity, etc., etc. So these are all the functions that you'll be calling to do things in your game. And this is LP API body.cs, so all these functions are related to bodies in Box2D. Now the final element that makes up this asset is the helper classes. So you've already seen those before. These are basically all these files here and in, let's say, joints, fixtures, and particles folder. These are the regular like C# monodevelop derived classes that Unity uses. So like these components like LP body, LP fixture, and so on. Okay, so now I'm just going to show you how this all works to actually make stuff happen. So this scene is getting a little bit crazy, so I'm going to start a new scene. Okay, And sure, as you remember, the first thing you always have to do in a scene is drag in the LP Manager prefab. So we'll go to prefabs, LP Manager. Okay, so I'm just going to make a few things in this scene, so there's something relevant in it. So I'll just create an empty game object, go to component, liquid physics 2D, and I'll just add a box, and I'll just make it a bit wider. And now I'll add a particle group, create an empty game object, component, liquid physics 2D, particle group, square. Okay. So now there's something happening in our scene. So now let's have a look at this LP Manager class. Now this is as its name implies, the class that manages the simulation, and it's probably the most important class in your scene anyway. So we'll click on Edit Script and just have a look at this. Open up MonoDevelop. Okay, so let's just start looking down through this class. Okay, so first thing to note is that there's an array here of LP particle systems. So, like we saw before with these child particle systems, the LP Manager actually keeps a list of all those, or well, an array of all those. Also, if we look down here, we see this dictionary, which has got an integer as the key and the LP body as the value. And this is similar to the list of particle systems, but it's just a way of keeping track of all the bodies in this physics world. So I use a dictionary because I want every body to have a unique key identifier, and I don't want there to be any kind of confusion with that. Another really important thing we can see here is we see this thing called an int pointer, which you may not have seen this before in C#, but what that actually is, it's just a pointer to memory location. So if you're familiar with C++, it's the equivalent of a pointer. And we'll just scroll up and we'll just see that I'm using system. So int pointers included in the system namespace. So you might want to include this in your scripts if you're using int pointer. I tend to use the lists quite a bit, so I'm also include a system.collections.generic. So the reason we use these int pointers is because we're communicating between C# and C++. We can only pass primitives back and forth, so only integers or floats. And if we want to pass anything else, like an object or an array, we can only pass a pointer to it, like a reference to it. So the way this asset is designed is that all these classes, which are components in Unity, are basically represent actual classes within the physics simulation. So in this case, the LP Manager represents the world, the LP particle system represents a particle system, the LP body represents body in the world, and the LP particle group just represents a particle group within a particular particle system in the world. So I'll just keep going down through this class, and yes, we see on the awake method. I do the initializing in the asset in the awake method because it's called before start. So you can do anything you want in the start method, and all the liquid physics 2D stuff should already be initialized, so you hopefully won't get any problems there. Now we have a look in the awake method for the LP Manager. There's an important and kind of revealing piece of code here, where we actually create the world. So you can see a world pointer, which is this end pointer field that we have. I'm making it equal to lp API world.create world, and I'm passing in 2 floats for gravity. So this is one of our API functions, and as you can see, you pass in the gravity floats and it gives you back an in pointer, which is a reference to the world object, which contains the entire simulation. Then you can see what I do next is I get all the bodies which have already been set up in the editor, and it initializes all those. So what it actually does is it takes the LP body, which is our C# mono behavior derived class, and it calls the initialize method on those. And this is a common theme. You'll see initialize coming up a lot, and what initialize usually does for one of my classes is that it creates that particular thing in the physics system. Then we create all the joints, then we create the particle systems, and the particle systems they create their own particles. Similarly, the bodies, when they're initialized, they also create all the fixtures attached to them. So now the fixed update method. So the way the LP Manager is set up to run by default is that the world steps during a fixed update. So that's where you do physics things. So the world steps completely irregularly, and during the update statement, we actually get the positions and rotations of all the bodies, and the positions and colors and other information, if we want, of all the particles, and we draw them. And I think this is quite an efficient way to do it, because it means that if you don't want to actually draw them, then you don't want that information. Obviously, you can get it at any time for your gameplay mechanics, but I think this is a quite efficient way of doing it. So yeah, we see in fixed update we're using LP API world and this function called step with particle iterations. So this this is another very important concept we see, is that the very first parameter in this function is we're passing in world pointer. So we're passing in that pointer that we got at the beginning in the awake method, and then a whole load of other things. And we're passing in this basically so on the C++ side, it basically casts this thing back into the world object, or the pointer to the world object, and then it's able to do stuff with it. So okay, so that's the LP Manager class. Another class I'll just show that's probably important is this is called LP Thing, and it's basically the base class for most of the actual stuff that exists in the physics system, or has a representation in the physics system in this asset. So just have a look at this LP Thing, and once again you see this end pointer structure. So basically bodies and fixtures and particle systems, they're all derived from LP Thing, particle groups, and they all have they all keep a pointer to the thing they actually represent in the C++ library. And also they all have this function called getPointer, which returns it. I just I felt it was important to leave this protected so that there aren't any weird orphaned pointers or memory leaks or anything going on. So I specifically wrote this function just to get the pointer. So you'll use this a lot when you're using the API functions. You'll, let's say get the body you want to do stuff with, you'll call getPointer and get the pointer and then pass that into the API function you want to use. And if this isn't making sense now, don't worry, because I'm going to show an example of it in a few minutes. Also, they all have this delete function, which is very important, and what this will do, you can see in the summary, it removes it from the simulation, and also deletes the associated Unity component. And in the case of bodies and particle systems and so on, it will sort out what the manager as well. It will remove the reference in the manager to that particular thing. Okay, so next thing is I'm just going to have a look at one of our scenes, one of the example scenes, and I'm just going to kind of show you how it works. So I'm going to pick this, the acid scene. So now we've kind of seen this before briefly. I'll just play it again because it's pretty cool. Yeah, the gizmos are disappearing, but who cares? Awesome. Okay, so let's have a look here in the scene. We see I have a object here called Dissolver, and it's got a script called Dissolver. You also notice that it doesn't have the LP prefix. That's because I have a lot of scripts in example scenes. They're here in this folder, example scenes scripts, and I don't really consider them canon, as it were. You know, an actual part of the acid. They're more just things that I wrote for the example scenes, just to show how to do stuff. And you know, by all means, you know, copy these and edit them and use them to learn and use the acid. So we'll just have a look at this now. So here's what it's doing. First, we're keeping a reference to the particle system. We also have this LP particle material field, which you can just see it here. You know, where I've created a material, I've dragged it in, and then it's just doing something every fixed update. Now, you know, you don't have to do this on fixed update. You can do it whenever you want. Actually, it doesn't matter because this will happen as independently. You know, as a kind of an enclosed sort of a function. So what we're doing here is we're getting a list of all the contacts in our particle system. So the particle system, which is this LP particle system, sys, has got a function called getParticleContacts, which you know, it's nice. You don't need to worry about how it works. It just returns a list of these LP system part contact. I think they're structs, yes, with information on contacts. So we just get all these, and also we're keeping record here which thing is this. You've got stone and acid. This is user data values, by the way, which you've seen before in the scene with the multiple particle visualizers. So then we're going through the list of contacts, and we're just saying if particle A, if its user data is equal to acid, is 1, and particle B in this contact, if its user data is equal to stone, then we want to do stuff with it. And in this case, I'm actually just adding the particle B's, which is let me just check. Particle A is acid, and B is equal to, yeah, okay. I'm just getting the stone particles index, and I'm just adding it to this list. The reason I'm doing that is that I just I like doing things in batches. I'll just explain that a little bit more. We'll go back to the API functions. You can see we have API groups of functions for body, contacts, fixtures, joints, and you'll see because this, you know, I think the particles are going to be the most important element for people. I have a lot of different functions you can call to do with the particles. So there's separate API functions for doing things with the entire particle system, or doing things with just a particle group, like the groups that we create, you know, like this, and just doing things with individual particles, so like one or more particles, so batches of particles. So have a look. Let's say this is a good example. Set selected particle flags. So this will just set the flags on a selected amount of particles. So it could be one particle, it could be 10, it could be 1,000, and it's anyone's you want. And so the way you call this is first you pass in this in pointer, which is the pointer to the particle system, because you need to tell it in which particle system to make the changes. And then you pass in this array, and it's basically just an array of ints. And what this is, it's just every int in the array is just the index of a particle that you want to do this particular thing to. In this case, change the flags. And just I may not have explained this before, but in a particle system in Liquid Fun, the particle system is really just a huge array of particles, and they just go from 0 to 1,000,000 or 1,000 or whatever. And it's the particles aren't really objects by themselves, so they're just identified by the particle system they're in and their index. So we do stuff to them by their index. So if you wanted to change the flags on particle 1, particle 5, particle 3, you'd pass in this array with 1, 5, 3. Now, slightly more complicated than that, because you also have to add an extra int to the beginning of this array, indicating the length of the array -1, the actual amount of particles you want to change. And this is because, once again, passing stuff between C++ and C#, you can't pass objects, so C++ won't know how long the array is, so you just have to tell it. But don't worry, this is all explained in the comments here, so should be fine. Okay, so we'll go back to we were looking at this dissolver class, so I'll just open this up again. Sorry, it's actually here. So anyway, so we're getting all these indices of all these particles. So we're finding out whether an acid one and the stone one have got a contact between them. Then we're adding all the stone ones to this list, and then we're saying if there's more than 0. So if an acid particle has hit a stone particle, or several of them. Here just to see this line, indices.insert 0 indices.count. Here's where we're actually adding the length of the list to the beginning of the list. So we can tell C++ how many actual changes you want to make. And then we're calling another API function, LP API particles, set selected particle flags. So this is actually the one that I was just looking at earlier. So this is a very good example. I'll go through this in detail. So first parameter is sys.getPointer. So sys is our LP particle system class. So we're calling getPointer on it. We're getting that int pointer struct, which is the first parameter. The next one is this list we've made with the added length to the beginning to an array. And the next thing are the material that we actually want to change the flags to. So they're not really important, but basically the material class has got a function called getInt, which basically the particle material flags are actually set in this extremely efficient way that uses a single integer to represent all the different combinations of different materials you can have. So you don't need to worry about it. It uses bit masking. Just don't worry about it at all. Just call this function and use this when you want to set flags. Then the next thing we're doing is it's very similar to above. We're just calling another one of these API functions for particles with the particle system. Also that same array, and all we're doing is we're just setting the user data to 0. So basically, we want to stop these stone particles interacting with the acid particles now, because they're not stone anymore. They've been turned into sludge. So there's no point continuing to check this. So we're just setting their user data value to 0. Okay, so I hope that that made sense to you, and you're not all just crying or something. I'm going to do another example now. I'm just going to this is probably a quite advanced thing that's going on here. I'm going to just do a really simple example of just how you would write a script yourself that uses the API to do something in your game. So I'm going to go back to that really simple scene that we had earlier. Okay, so we're back in that simple scene we made before. It's actually empty because I forgot to save it, so we'll just add a few things just so it's not empty. So I'll just say create empty component LegoPhysics 2D collider box, and I'll make it a bit longer. I'll add a particle group, LegoPhysics 2D particle group square. Yeah, go away, Dropbox. Make it a bit bigger. Then I'll add a dynamic body, so create empty component LegoPhysics 2D collider circle, and I'll just set this body type to dynamic. Okay, so now we've got some kind of scene. So now I'm going to just write a script from scratch that just uses the API to do something to something in the game world, and we'll just I think we'll just add an impulse to this body. So right, first we need a new C# script. So just right click here in project view. I'll say create C# script. We'll just call it add impulse, and I will drag it onto this ball. It doesn't need to be on the ball, obviously it can be anywhere you want, it doesn't make any difference. So we'll just open up this new script in MonoDevelop. Okay, so first thing we're going to want is a reference to the body. So we'll just say LP body. We'll call it bod. And yeah, we'll make it so that at start it just goes and gets that reference. So we'll say get. Oh no, we'll say bod is equal to get component. And we'll say LP BODY. By the way, it's I don't know if I mentioned this before. You'll definitely see it when you start using the library. But the way this works is that there can only be one body per game object, and that if you have a shape like this box or this this circle, you must have a body, but there can only be one. You can't have two on the same game object. That's because the game object's position and rotation represents the actual body's position and rotation of the physics engine, and so there can only be one of those per body. So anyway, so there we go. Bod is equal to that. So that's fine. So I'm just gonna write a coroutine really fast because it's just a handy way of doing something over and over again. So we'll just be certain that our script is having some effect. So it's enumerator, and we'll call it add the impulse, and we'll just say while true. This is so this will keep running forever. We'll say, oh yeah, yield return new. Oh, whoops. Wait for seconds, and we'll just say 1 second. So this coroutine will run every second, and we'll just start it in the start method. So start coroutine, and it's called. I'll just copy and paste this so I don't make a typo. Okay. By the way, if you're not familiar with coroutines in Unity, then just don't worry about any of this. It's got nothing to do with the asset. It's just a way I like doing stuff. So I mean, you can do this. We could have done this in the update statement and waited, or we could do it loads of different ways. So this is not really relevant. But I'll just throw in a debug just to be sure that this is working. You know, we're not in any hurry. Okay, that's a good debug statement. So let's see. Okay, so we got our scene running. We've got our coroutine running, blooping away there. Okay, yeah, we don't need this anymore. Right, so now we'll actually do something. So we're going to do something with this body. So what we'll do is we'll type in LP. So everything in the asset, you know, every official part of the asset has got the LP prefix, and then we'll say API because all the API classes have got a API prefix. So then we can see a list of the potential things we want to use. So we're going to want LP API body because we want to do something to a body. So we'll just hit enter, and then we'll see what functions we have here. We have a lot of functions, obviously create body, delete body, apply torque, get info, blah blah, you know, lots, many functions. So a nice, really simple one is just apply force to center of body. You don't have to worry about angular momentum or where the force is. You know, we're just gonna basically kind of accelerate this body a bit. So okay, I'll just choose this. Oh yeah, and by the way, you can see the XML comments showing up there in the summary, and we'll get the same thing there for the parameters here. So we've got the description of the parameters in the summary. So the first parameter is this system.inPointer body pointer. I'm just gonna add using system because we're dealing with inPointers, just to be safe. As you saw before with these inPointers, they're the pointer to the object, and each thing like a body or a particle group or a particle system or the world or a joint just holds a reference to that, and you use the get pointer method to get it. So we've got a reference here to our LP body object. So we're going to say bod dot get pointer, which will give us the pointer for that body, and then we just forget about that. So that's a lot of the time it's the first parameter you'll pass when you're doing something, just to tell the C++ side of things which object you actually want to do the thing to. So for the impulse, I guess we'll just make a public field here. So we'll just say public, say vector2, and we'll just call it impulse. Okay. And we'll just say this is impulse dot x and impulse dot y. Okay, so that ought to be us done. So go back to the editor, have a look at this thing, see the impulse. So we better give it a value. Let's just give it a giant value and just see what happens. So every second an impulse ought to be added to, or it's actually a force. Sorry, excuse me. We're using apply force center of body. They're quite similar. I think the difference is an impulse will just change the body's velocity no matter what, whereas a force takes into account its mass. So let's just press play and see what happens. Okay, nothing happened. Okay, let's try that again. So yeah, not much seems to be happening, but maybe the force is just really tiny. So let's just make it super big, make it 100, 120, and the X. Oh yeah, okay, there we go. That's working. So you can see it's a positive. So how about we make the x minus, make it like, yeah. Well, let's not make it too big. Let's say minus 80, and we'll make the y one super big, because let's say we want the ball to fly up into the air, so we'll make the y one like 300. So now let's have a look. Okay, so yeah, okay, maybe 300 was a bit too big. We'll try 150. So yeah, there we go. Our thing is going off into space. Okay, so that's the basics for how you write scripts for your own game. You know, using these API functions to kind of do what you want. You know, earlier we looked at that the ACID script, and I would just say that you know, if you're a programmer, you know, looking through those example scenes, looking through the scripts that I've done to do stuff, I think would be very, very helpful for you. You know, just as further examples like we just did now. So let's say I'll just open up a scene. Let's say also looking at the scripts on the prefabs would also be very helpful. So in the prefabs directory, there's a subdirectory called prefab scripts, and these are also really good. So if we go to example scenes, let's say this one, I won't bother saving this. So, you know, you'll be able to find out how to do a lot of things just by looking. So let's, if we look at the particle spawner script, for example, you can see that you know, there's some kind of just safety stuff here, but then it what it does is it actually just it creates a new or it creates either a new particle group or just a single particle in the system, like every certain amount of time. So so what it has is it has a reference to this particle group, and it's just saying to that particle group, basically spawn thyself every time. And just one of the settings it happens to have is it has this setting called only spawn one particle. If you just want to just, you know, be spitting out one particle at a time, and in that case it just calls this LP API particles dot create particle in the system, which is a function that just creates one single particle in your particle system. And then there's a bunch of parameters. There's the particle system itself, there's the material, there's position, there's color, there's you know, lifetime. These are all just simple primitives. Actually, while I'm here, I'll just mention one thing. If you have a look at this bit here, it says LP man. So that's the LP manager. So in this script, I'm keeping a reference to the manager. You can see, I think we're just setting that it gets the manager here and start, and then it's getting lpman.particle system. So this is, we saw this earlier. It was this public array of all the particle systems, and then we're getting the one that I'm in. You know, because you could create particles in different systems from that array. So we're basically getting that particle system from the LP manager, which keeps a list of them, and we're calling get pointers. So essentially we're just getting the pointer to the particle system. You know, another way you could do this if you're writing your own script is you could, you know, make a public field here for particle system. You could, you know, drag it in the unit in the editor, and then you just say, you know, whatever sys, whatever it's called, that get pointer. Okay, so that's the end of this video. Thanks a lot for watching. I hope it wasn't too confusing, and if any of you are, you know, still scratching your heads or have anything you'd like to add or just discuss, then absolutely get onto the forums and, you know, start a new thread. The link to the forums is going to be in the description below, and thanks again for watching.